use a calculator for this. So there's this row total and column total, and then there's this super total. So what you're supposed to do is come up with what's called an expected value for
Okay.
each of these cells. And so let me call this E11. Find the value in E11. You take the row total, which is 189, times the column total, which is 248, and you divide it by the super total, which is 628, like that. Okay.
Oh,
And
okay.
so you end up doing this for all of them. So this the value that goes in here, you have to do this 9 times. So it's actually quite a bit of
Oh,
work.
okay.
We're not going to do it all. I'm going to use the calculator computer, but I'll just put another one up as an example here. Is that okay?
Oh, yeah.
All right. So what I'm going to do here is just go off to the side here and pull up a calculator for us. Actually, we
So
actually don't
on
need
the
that.
actual test, does he expect us to do that? That's crazy.
My guess is no. My guess is that you will not be expected to do that on the test. They'll just give you the results, but maybe. All right. So the null and alternative hypothesis here for question 1. I'm going to pull up. All right. So the null is that they are independent. So there's actually a few different ways that this can be. They sometimes use like other words like relationship, association, but this is typically the one here that they use for this.
Independent.
So let's go with that for the first one.
Okay.
And then for the second one here, that's where we actually have to calculate that table and do some other things. So I'm going to go grab find a calculator here that we can use for this. All right, so I just need to enter the data. Oops, that's not what I wanted to do. Apologize. All right, sorry, too much. So I'm now entering this data into a calculator to be able um, to be able to calculate the chi-squared value, which is what it's asking for in the next question. Um, if you would like more explanation, I'm happy to give it, but you need to enter these numbers.
Okay.
All right, so that one didn't work. That's the one I want. Yeah, so what I'm doing here is using a calculator to find the chi-squared statistic. So I just need to enter these values in. All right, and here we go. 75, 61, 53. So the calculated chi-squared is 0.5552. So you can see that's these two. And
Mm-hmm.
then the degrees of freedom calculation is the number of columns minus 1 times the number of rows minus 1. So if you go back and look at your table, you have 3 columns and 3 rows. 2 times 2 is 4. So this is the best choice there. Any questions on that before we move to the last one?
Well, the chi-square, how did you get that number? Is it all those
So
that?
you have to calculate these 9 values,
Oh,
and then what you do is you take the observed value, which comes from the table here, you subtract the expected value, you square it, and then divide by the expected. So you do that 9 times.
oh, Jesus. Okay.
Yeah, not ideal. Okay, so the p-value here, which we need for the next part of this, the p-value is 0.0331. 0.0321. Okay, so now I'll pull up the answers here. So p-value 0.0321. Since the p-value is greater than 0.021, so it's one of these that's greater than. We fail to reject. There is sufficient evidence to conclude that they are not independent. Insufficient evidence. So I gotta go back and read it. Not independent. There is sufficient evidence to conclude. Yes. Okay. So it's this one right here. It's very nuanced. It's this word and these two words there. It's related back to the alternative hypothesis, which we saw in part.
But didn't we say
Question
it
one.
was independent?
So we're saying that there's not enough evidence to prove that it's the alternative, that it's not independent.
Oh gosh, all these word games.
Yeah.
Okay. All right, I'll pick those and let's just see what happens, I guess. Okay. So first one.
Whenever you're ready, if you want to share your screen again, we could look at some more questions, or if we gotta make any corrections to this, let me know.
Okay, I'm going back. Okay, so that one was correct. I have to go back and get it. Okay, this one has 4 questions.
So let me grab some snips here. Give me just a moment to grab these. All right. Question one. All right, I got it. If you want to scroll down to the next one.
Oh, question 2.
Yep.
Okay.
Grab it there. All right, got it. All right, I got all the questions. We can go ahead and get started here. All right. Okay, so what they're saying here in the start of this is that they did it. They went and sampled 500 and they found that these were the observed values. So 120 catfish, 85, so on. There's also what's called the expected value. The expected value is you take this percentage and you multiply it by the 500. So for catfish, 30% times 500 is 150. Bass, 75. 40% of bluegills is 200. And then pike is also 75. So these should also add up to 500. The quick check on that, they do. All right. So now to answer question number one, we'll need this for part 2, but to do question number 1,
Okay.
you're basically like, is the distribution, actually I take that back. Is independent. Okay. So is independent is not independent. So it's actually the same thing as before. Is independent not and
Okay.
although, well, reads really oddly. I'm very conflicted here because usually it's usually the different distribution of fish is this, the distribution of fish is not this. Let me do a quick Google search. That up. No association. There's an association. All right, we'll go with this. Uh if not, we'll adjust. We got the second attempt there. So the question two is figuring out the chi-squared. So the formula for it, this is what you're asking for. It's the summation of the observed minus the expected squared over the expected. So what we have to do is go back to that table that we're creating here. And basically you take the difference of these numbers, like 120 minus 150, you square that result, and then you divide by 150. So I'm going to do that in another screen here. I don't know. This one's reasonable to do by hand, maybe. I mean, it's not great,
Nine
but it's not terrible.
9.6267. Is that right?
Yeah. So I'm gonna get them all here and then
Mhm.
give you all the answers. 85, 220. She made these pretty nice. Okay. So here are the results. And you just have to, so is that really 75? It was, okay. So you just have to add these numbers up, you end up getting 9.33.
Oh, okay. I was doing different. Okay.
All right, so the next thing here is to find the p-value for question three. So the chi-square distribution has the shape. It's like that. So you've got a 9.33. We're finding the area over here. So the degrees of freedom is the number of rows minus one. And this problem, so you have 4 rows. So degrees of freedom is 3. So you just got to find your favorite chi-squared calculator. And I'm going to grab mine here and see if I can calculate this for us.
Is it 0.001 or am I off?
I'm not sure. Let me see here. Chi-square. Here's from 3. I got 0.02, 0.0252.
Yeah, I'm off. Okay.
So it looks like it's right there. Now, good news is this is less than 0.05. And the reason that's important is when you get to the next question here, they're all at the 5% significance level.
Mm-hmm.
So that means 0.05, since it's less than, you reject. So we're either doing that one or that one. All right, so actually this does help us to answer the first one. That's really good. Has fish. All right, so it looks like this is the right answer, and we're gonna have to go back and change the first one.
Okay.
So it means it has changed. So we're gonna change our first answer to, sorry, that's the wrong question. Sorry, I'm in the wrong place. Oops. Okay, it's that first one.
Okay. Okay. This one has 14.
Okay. I'll need to grab, yeah, if you go up. All right, let me grab some of those.
Looks like
Is this the last thing you wanted us to work on today?
one more and that's it.
One more. Okay.
I don't
So yeah,
know.
you can scroll down to number 1. Right. I got 1 and 2. If you want to scroll down to 3 more. Five. Wrong thing. Snipping tool. Grab the wrong thing. All right. 5. Grab 6. All right. I got 6. So let me. Yeah, you can go scroll down to section 2, please. Grab that top stuff first. I don't know. I assume we're going to need it. All right. And then you said 7. You can scroll down for 7, please. All right. 8. Let's go to 8. All right. I got 8. Got 10. You're going to go down to section 3. Let me grab that. 11 here. All right. You can go down to 12, please. I got 13. You're going to go down to 14. All right, thank you. Got them all. Get started here. Let me share my screen. Okay, so first question number 1 asks about this value A, which is the expected value in cell 1. And we know which is cell 1. Yeah, okay, I see. It's the one with 62 in it. All right, so to find A, you take the row total 107 times the column total 186 and divided by 406. And I'll just grab a calculator for that. And ends up being 49-ish. Let's see if that's one of the answers.
49.
Yeah, so ends up being 49.02. And then B is the next thing it asks for. B is the cell associated with 45, which is right there. That row total is 107 times the column total 220 over 406. So just do that calculation there. About 57.98.
Yep, right on the dot.
And then what's the next thing? So for C, C is a little bit more complicated, but not for me. So if you look at C, C is right here in this row. So to find C, you take the observed, which is 68, minus the expected, which is 74.22, just using those two values there.
Oh,
Square
okay.
it and divide by 74.22. And I get 0.52.
Yep.
All right, let's see what else it asked for. It asked for D.
Hmm.
So D is down here. So you're looking at the 56 cell. So to find D, it's the row total, which is 137 times the column total 186 over 406. So 62.76. All right, so cell E is the end result here. So you got to take your result from C. Your result from C was 0.52. So we just got to add up all these numbers here in this column. I got 8.66. Is that an answer there? Yeah, it is.
So what did you get for D? Did you get 62 point? No.
Yes. Yes.
Oh, okay. I got the wrong one.
Okay. Any questions on that before we move on to 6?
260. No.
Okay. So 6 requires us to find the p-value. So we need the degrees of freedom. The degrees of freedom is the number of rows minus 1, number of times the number of columns minus 1. So there's two columns, 2 verticals, and 3 rows. So your degrees of freedom is 2 minus 1 times 3 minus 1, which is 1 times 2, which is 2. And so you're looking, your chi-square distribution, 8.66, degrees of freedom 2. You're looking for that value out there. So you go to your handy calculator and you get 0.0132. 0.0132. Okay, now we can actually answer the question without the p-value, no chance of answering it. So it says at the 5% level of significance in all of them, so that's 0.05. Yours is less than 0.05, so you're going to reject. So if we're looking for the one, reject. There is evidence to support that they're not independent.
So never fail to reject. It's always re-reject, right?
If it's less than the p-value.
It's less. Okay.
All right, any questions before we move on to section 2?
No.
All right, so the thing that they're not giving you here, I guess it doesn't matter yet for the first one. Let's go to question 7. All right. The null hypothesis is that they are the same and then not the same. Same is like the equals, not same is the not equals that we've been doing all along here. Okay, if we go back up to this table here, the degrees of freedom is the rows minus 1. There's 2 rows times the number of columns minus 1. There's 4 columns minus 1. So the degrees of freedom is 1 times 3, which is 3. If you look at the answers for question 8, there's only one with the right degrees of freedom. That third one there. The 9.31 was given in our table here. So that's why that's correct. find the p-value, you again have to use some sort of a software package. Finding the area out here in the tail, you need to know the degrees of freedom to do that. So it ends up being p-value of 0.02544, which is that one right there. The level of significance is 0.05. So the p-value is less than the alpha of 0.05. So we're going to reject, reject. So one of those two. And there is sufficient evidence to conclude do not have the same. So that's the other word we're looking for. Have the same, do not have the same. All right, on to section 3. So question 11 here. We've done this a couple of times here. It's the null hypothesis is always the one that has the same. Same means equal, different means not equal. You have to have an equality in your null hypothesis. Okay, so this one's a little bit more involved here for question 12. You have to actually calculate the expected values. Okay, and so to do that, you take each of these percentages here and you multiply by the 1486. Okay, so I'm gonna do that in some software to kind of speed this up a little. Give me just a moment here to enter this information. One 62. I missed one. Almost there.
No, you're good.
All right, so here's the table, and you can see, like I said, the expecteds I had to calculate. The observed are as given, and then you do the chi-squared calculation. So it ends up just being 0.1984 as the chi-squared value there. That sum. So you can see that that's consistent with this here. The degrees of freedom is the number of rows minus 1. You've got 5 rows. So degrees of freedom of 4. So it looks like that is the best choice there, that third one. The p-value. You see a lot of the same things. You take that chi-squared value, 0.1984. It's going to be pretty large this time. You can get a sense for that because of how small the chi-squared value is. So it ends up being, the p-value ends up being 0.9954, 9954. It's like it's that last choice there. It's unusual. It's unusual for it to be that large. Okay, and so this is much, much greater than alpha, so we fail to reject. We'll see that in the next question that we're going to fail to reject.
So 3 of them.
We fail to reject, fail to reject. F include, yeah, this one here. So this, the regional distribution of raw materials, the current, yeah. So
Not the last one, right?
Good question. Yeah, I believe it's that one there, that one I selected there.
Okay.
Okay, might be some mistakes. We'll see. Trying to get through that so you can get that last thing done you needed today.
92. So
Looks like there's one wrong, so let me know which one that is. Maybe I can quickly tell you what it is. Might be the last one.
it lets me back in. Question 1.
This one, the value of A.
Let me double check. I'm going in there right now. Oh, question 14. Shoot.
Okay.
Yeah, question 14. Sorry.
Yeah, so we failed reject. It was insufficient include. So I guess I would switch to this other one here.
The third one or the second one?
Yeah.
Okay. Nope. It was the last one, I think, or whatever. It's okay. 92 is fine. All right, so the last one. Oh, 7 questions on this one. Can you see?
Yeah, we might do this verbally here. This looks like that R stuff, so I may not be able to do it. We'll see. Could you just scroll all the way down so I can see what else you got? All right, keep going. Keep going. Going. Keep going. All right.
Kind of the stuff you just went over.
It is. Some of this will be. We'll see what we do. All right. Yeah, I guess I'm gonna grab some pictures here. So if I'm gonna scroll up. All right, let me grab that first part.
Okay.
All right, let me grab question 1. You're gonna go down to question 2, please.
Oh, this question.
All right, question 3. Right, you can scroll down to the next part. You grab all that. Got it. We're gonna go to question 4. Got the question.
What?
I need to get 5 real quick. Right, question 6. Got it. And then question 6, 7. All right. Let me grab 7 here.
You
I
got
did
it?
not grab. No, not yet. Okay. Got that. All right. So first question here is about what type of test to use for the given data set. So we're looking at eye color, and we're looking for yeah, okay, it's a little weird. There are three types of chi-square tests: independence, goodness of fit, homogeneity. Um, Goodness of fit is like for a particular distribution. That is what they give you in the like given stuff here. They're talking about distribution of hair colors and stuff. So we're gonna use that one for, we're gonna go with that for question one. So for question two, they give you the p-value. They say it's 0.0248. We don't know. We don't know the level of significance. Oh, it's 5% level. So we're going to reject. We reject the null hypothesis and do not believe distribution. Fail to reject. All right, so I think it's this last one here.
Fails to reject.
But I think I need to look back at something real quick here. No, we need to include the percentage. So I think we have to include the percentage. That's the only difference between these. So let's go with the third one. Okay, so question three is about something totally different. It's a one proportion test. I'm just gonna run the test here and see what I find out here. So I'm gonna do that in StatCrunch, the piece of statistical software. You put the output in the window here. Don't need all that. So we're doing one sample proportion test with summary. All right, so 257 out of 500. And then we believe that it's 0.45. Significantly different, compute. All right. So the output of this test in the other piece of software I have here shows us that the p-value is 0.004, which is less than 0.005.
Okay.
So
Can
we'll
you
go with that.
write that down on the side? That
What?
software. you're talking about?
Oh, I use StatCrunch. I mean, there's a million of these that you can just find one. That's just one I have access to.
Okay.
You're supposed to use R, but that would take too long to figure out. Okay, next question here is new data set. All right. Um, so the data set they give you, you can look at that if you want. The question is about it's like which type of chi-squared test is it? Is it independence? Is it homogeneity? Is it goodness of fit? So it's not goodness of fit because it's talking about an association.
You think it's homogeneous?
Association. So it's either independence or homogeneity. I tend to think of it's independence, but I can double check that. It's if it's not that one, it'll be the other one. So maybe we'll just figure that out at the end. All right. So the degrees of freedom for this test is the number of rows. So you got 1, 2, 3, 4, 5, 6, 7. Nope, 6 rows. The total doesn't count. 6 minus 1, which is 5. And then chi-squared test. So this is the one that I don't know. I don't know that we're going to be able to do because it's
A lot.
It's, yeah, I don't even know.
What's your,
So,
let's do your best guess. Let's do your best.
yeah, well, they've done a nice job disguising them. So it's not this one. Let's go with this one,
Okay.
that one first, and then the confidence interval. Maybe we'll be able to, ooh, this actually could help us. Do they all include zero? Yeah, so it's probably, it's either this one or it's gonna be the other one. There's no way to do this without the software, so let's see. Um, Mer and Said. Um, Let me just do some calculations here real quick. I don't know without doing, without doing the software. Let me see if I can quickly. 0.039. 0.081. That's not right. A minus. I couldn't tell you. There's no way for me to do for different. Oh, difference in proportions. Okay, hang on. We can do this. CVD, Mur, and Syed. Okay. BVD, Mur, and Syed, and pretty small. Let me try one. Let me try this once in StatCrunch. Maybe we will get something. Do sample with summary. Okay. CVD is 7. See, I don't know whether it's, I guess 7 and 12. It's 7 and 12. Okay. So 7 out of 173 and 12 out of 154. And we're doing a 90% confidence interval. Minus 0.0. So that didn't work. Let me try one more thing. Um, for male, no, they do male. Oh, that's what is male. Okay, that will help. 91 out of 173. No, 7. 7 out of 173. Okay, please work. 0.0601. And I'll try one more. You have no idea. Not there's some, I'm not there's some information I'm getting in here. I don't know. Go with that one. That one looked okay.
Okay, let's try it.
And see what we need to recorrect here.
Ooh, 66. Okay, so let's see.
All right, so let me know which ones here give you
Okay.
better guesses.
Question to answer 2. So we missed 2. So it's 4. Question 4. So it is the homogeny one, I think.
Yeah,
Question
so go with
4.
yeah, go with that one. And I'm guessing it's the 7.
And then 7, yeah. And then, well, we don't know. We just have to just pick whatever.
Maybe go with that one if you want.
Okay. Mhm. Here we go. 86. So Cool.
Okay.
I'm good with that.